Hey y'all. All right, so I just wanted to walk through a practice problem just in case we forgot what was going on. We can review together, and then you guys have the rest of the worksheet to complete all on your own. So in the first review problem, it says a 5,000 kilogram car A, travels to the right at 4.5 meters per second and collides with a 3,000 kilogram B, traveling to the left at 2 meters per second. After the collision, car B travels 5 meters per second to the right and bounces off car A, which continues to move. What is the car A's final velocity and what direction is it moving? So what we're doing here is we're going to draw our model. But before we do that, let's highlight some information. So let's annotate our problem. It says a 5,000 kilogram car, which is car A, moves to the right. Remember, direction matters when we talk about velocity, and it's going at 4.5 meters per second. So we have a speed with a direction, right? And then it says car B is 3,000 kilograms and is traveling to the left at 2 meters per second. It says after the collision, car B is going 5 meters per second to the right. So we need to make sure we know that direction as it bounces off car A. And we need to know the final velocity of car A. So now that we know that information, we first need to draw the model of what's happening. We got to label the masses of each car, the velocities, and the direction it's traveling. So we first have car A. Car A has a mass of 5,000 kilograms. And something you might always want to do is if you put car A on the left side, let's do the same thing after the collision. We know that the mass is still 5,000 kilograms. None of our masses ever change. It says before the collision, it's traveling to the right. So let's draw our arrow to the right, and it's going at 4.5 meters per second. So we put that 4.5 meters per second on the arrow. We can even label it V if we would like. Okay. After then we have our second car, car B, and car B has a mass of 3,000 kilograms. So let's make sure you put that on both sides. Car B, which has a mass of 3,000 kilograms. And then before the collision, it's moving to the left. And that's going at 2 meters per second. And if we want to label again, V equals to remember its velocity, or you can just write the 2 meters per second above. That's fine too. And then remember, if it's going to the left, we can even in here put in a negative if we want to remind ourselves that this is going to be a negative velocity because of the left direction, because it's going the opposite direction of car A. After the collision, though, we know that car B is going to the right. So we can draw the arrow going to the right, and it's moving at 5 meters per second. So we can put that 5 meters per second in for the velocity of car B after the collision. Okay. And then it says we're looking for the velocity of car A. So we're missing this guy right here. So we want to put a question mark, leave it blank, however you want to signify that that's not something we know. Okay. So once we have all of our velocities on all 4 of them, we have our mass for all 4 of them, we have arrows on all but the one we don't know. We don't have to put an arrow on A because after the collision because we don't know which direction it's traveling. Now that we have all that, we can go ahead and set up our givens and our unknowns. So remember, our givens are always going to be our different variables from our equation. If you remember, the equation's always the same of M1 V1 initial plus M2 initial equals M1 V1 final plus M2 V2 final. It's always the momentum of each car beforehand is equal to the momentum afterwards because the total momentum needs to be conserved for a collision, especially an elastic collision. Now that we have that, we can go ahead and write down our letters, our variables. So we have M1, M2, V1 initial, V2 initial, V1 final, and V2 final. Okay, so we're going to look for all of those in our drawing since we have that now. And we can see that our M1 is 5,000 kilograms. Our M2 is 3,000 kilograms. Our V1 initial is 4.5 meters per second. Our V2 initial is negative 2 meters per second, again, because it's going to the left. Our V1 final we don't know, but our V2 final we know is 5 meters per second, which means we can cross this out over here and we can bring it into our unknown box since that's not something we know. Now that we have one missing variable, now what we're going to do is we're going to plug into our equation, just like we've always done. Okay, so now we're going to plug in, we know that the mass of car 1 is 5,000 times the velocity of car 1, which is 4.5 meters per second before the crash, plus the mass of car 2, which is 3,000 times the velocity of car 2, which is negative 2 meters per second before the crash, equals the mass of car 1, again, didn't change, so it's still 5,000, times our unknown velocity of car 1, so we're going to leave it as V1 final, plus the mass of car 2, which is 3,000, times the velocity after the crash, the final velocity of 5 meters per second. Right. Again, what I like to do is break it apart into smaller chunks. So I'm going to multiply this together first. So I'm going to do 5,000 times 4.5, and we end up with 22,500 plus. We can break this part down. We have 3,000 times negative 2, so we get negative 6,000 equals 5,000 times V1 final. Remember, we can't touch this because it has a variable, so we're just going to leave it alone. It doesn't get used until the very end. And then last but not least, we have our 3 times 5, so we get, or sorry, 3,000 times 5, so we get plus 15,000. Now that we've done all the multiplication we can, the next thing is combining like terms. So these both are just numbers, so we're going to combine these. And when we combine these, we get 16,500. And since we're not doing anything to the right side, we're just going to leave that alone. So we're going to bring down our 5,000 times V1 final, and we're going to bring down our 15,000. Now that we only have one thing on the left side, we want to try and get our variable with any coefficient it has to stay alone, which means we're going to take away the 15,000 from both sides. We're going to subtract it. So that way on the right side, it goes away completely. On the left side, we get 1,500 equals our 5,000 times V1 final. And then our last step is to get the variable all by itself by getting rid of the coefficient or dividing both sides by 5,000. And we end up with our V1 final is equal to 0.3 meters per second. Right. So now that we have all that information, we can even remember that our object, which direction it's moving. So if we look, our object, because it's a positive number, is still going to the right, just like it was before. But we can see that that velocity did decrease. So it's going to the right, but it slowed down. All right, y'all, we have 2 more practice problems that you guys can work on. If you have any questions, we can talk about it before the test tomorrow. So just send me an email or go to the science help desk, or just make sure to ask before we take our test tomorrow. Otherwise, have a wonderful rest of your day. And if you have any questions, again, send me a message or let me know tomorrow.